This is a lecture on recursion, and in particular, how you walk through the recursive algorithm associated with the little game called Towers of Hanoi. At this point, I'm assuming that you've already played the game Towers of Hanoi, so you understand the rules, and I'm also assuming that you have a copy of the Java code that implements that, because what we're going to do is walk through the Java code to see how it, in fact, behaves. So, here's the Java code. And a couple of things to note here. First of all, this is a complete program. It does it all. We do know that this is a recursive implementation because the essence of recursion is methods call themselves. Here I have the method Hanoi. That method Hanoi is being called initially from main, but this method Hanoi is also being called from inside the method Hanoi. This is the clearest indicator that this is being implemented as a recursive algorithm. What we need to do is walk through the execution of this to make sure you understand the process of recursion. So to begin, I'll start with this clean screen, and we'll begin. So the very first method call comes from main. I'm going to label this first method call as number 1. We'll label each one of the method calls because later on, as you get into more and more complexity in the recursive algorithms, you need to keep track of where you came from and how you're going to get back. So this 1 in a red circle is a very useful way of keeping track of the order. The other thing that I need to track is the values that are being sent in as arguments to the 4 variables. So you can see that I'm sending in 2, A, B, and C. The 2, of course, maps to the variable n, A maps to C1, B to C2, and C to C3. When I arrive, n has the value 2, so naturally enough I'm going to be performing the else clause since n is not equal to 1. And one of the very first things that I need to do here is make a method call. This will be method call number 2. Take a look at what I'm sending in. First argument is n minus 1. Well, currently n has the value 2. So when I send that value in, I'm sending in 1, which is just 2 minus 1. And the 3 characters that are coming in, notice that positions 2 and 3 are being exchanged. So I came in with the values ABC for C1, C2, C3, but because I'm exchanging the positions for 2 and 3, what I end up sending in is A, C, B. Great. I've arrived now with the value 1ACB in the 4 variables n, C1, C2, C3. One of the things about recursion that you need to keep track of, and that is these values that you see here, the 2, A, B, C, they still exist. But because of the recursive method call, the act of having sent in the 1ABC here makes these ones kind of invisible. They're still there, but they're buried more deeply on the stack. These values here, the 1ABC, have been pushed in and they are topmost on the stack. So when I come back to consider this, well, n, the most visible implementation or version of n, is indeed 1. So I will execute this output. And when I take a look at the contents of C1 and C2, what I'm looking at are the contents of the C1 and C2 associated with this instance of those 4 variables. So I'm outputting the A and the C. And up here in the top right corner in the yellow box, you can see that the AC matches the expected output when this is executed. I've just finished doing that output, and so now program execution is going to drop off the bottom of this method. So I'm returning. Where do I return to? Well, I'm returning to where I was most recently called from, which is number 2. So diagrammatically, to keep track of all of this, I'm going to stroke out 2 as an indicator that, yes, I've finished that method call. I'm also going to stroke out the one ACB because the values associated with those are going to be popped off the stack. They'll be gone forever. And I'm also going to add an arrowhead on the back end of this as a visual indicator that I've just returned from that method call. So the next thing I do is, after returning, I do the next statement, and in this case I'm outputting the values in C1 and C2. But the C1 and C2 values that I'm concerned with are now these ones, because these are now visible again. So I'm outputting the A and the B, and when we take a look in the top right corner, it matches. So A and B are output. I've just finished doing that output. I'm about to do the next line of code here. It's another recursive method call. This is number 3. And what am I sending in? Well, if I come back and take a look, these are the current visible values for the 4 arguments. So 2 minus 1 is 1. And notice here, of course I'm subtracting that, right? Notice here I'm exchanging positions 1 and 3. So the values that you see here for ABC, I'm exchanging positions 1 and 3. So it's going to be CBA. CBA. I arrive, and of course n has the value 1, so I'm going to output C1 and C2, and this is the most visible part of the stack. So the C1 and C2 means I'm outputting C and B. And there it is. It does indeed match what we see in the top right corner. And I'm done, right? Well, the screen output is complete, but I'm not finished yet because I'm deeply buried in a number of recursive calls, and I have to finish those. So I drop off the bottom of the method again. Where do I return to? I return to where I was most recently called from. In this case, it's number 3. So I'm returning there. These values that were pushed onto the stack are popped off the stack. They're gone forever. And I put an arrow indicating I've arrived back here. I'm right at the bottom of the method, so again I'm returning. Where do I return to? Well, now my return is to the most recent call, which is here. That disappears. That disappears. And I'll put the arrowhead on. And program execution is now finished.